Kubernetes is an open-source container orchestration platform that simplifies the deployment, scaling, and management of containerized applications. Its architecture consists of several key components that work together to provide a robust and scalable infrastructure for running and managing containers. Let's explore the architecture of Kubernetes. 1. Master Node. API Server. The API server acts as the central control plane for Kubernetes. It exposes the Kubernetes API, handles requests from users and other components, and manages the state of the cluster. ECT is a distributed key-value store that serves as the cluster's database. It stores the configuration and state information of the cluster, allowing for high availability and consistency. Controller Manager. The Controller Manager runs various controllers that monitor and manage different aspects of the cluster, such as node status, replica sets, deployments, and services. Scheduler. The scheduler is responsible for assigning containers to nodes based on resource requirements, availability, and other constraints. It ensures optimal utilization of resources and load balancing across the cluster. 2. Worker Nodes. Kubelet. The kubelet is an agent that runs on each worker node. It communicates with the master node and manages containers on the node. It ensures that containers are running and healthy, and reports the status of nodes back to the master. Container Runtime. The container runtime, such as Docker or Containerd, is responsible for running and managing containers on each worker node. It pulls container images, creates and starts containers, and handles their lifecycle. 3. Networking. Kubernetes Network Model. Kubernetes uses a flat network model where each pod gets its unique IP address. Pods can communicate with each other directly using these IP addresses. Container Network Interface (CNI) plugins provide networking capabilities to containers and manage network connectivity within the cluster. They handle tasks like IP address allocation, routing, and network policy enforcement. 4. Controllers and Workloads. Replication Controller. The replication controller ensures that a specified number of pod replicas are running at all times. It monitors the desired state and automatically adjusts the number of replicas as needed. Deployment. Deployments provide declarative updates for pods and replica sets. They enable easy rollout and rollback of application updates, versioning, and scaling. Stateful Set. Stateful sets are used for managing stateful applications that require stable network identities and persistent storage. They ensure ordered deployment and scaling of pods while maintaining uniqueness and stable hostnames. Daemon Set. Daemon sets ensure that a specific pod runs on every node in the cluster. They are typically used for system-level tasks like logging, monitoring, or networking. Jobs and cron jobs. Jobs manage batch or one-time tasks, while cron jobs schedule jobs to run periodically based on a defined schedule. 5. Services and load balancing. Services provide stable network endpoints for pods. They abstract the underlying pod IPs and enable load balancing and service discovery within the cluster. Ingress resources define rules for routing external traffic to services within the cluster. They act as a reverse proxy and allow external access to services. Kubernetes architecture is designed to be highly scalable, fault-tolerant, and flexible. Its components work together to manage the lifecycle of containers, ensure high availability, and provide advanced features for deploying and scaling applications in a distributed environment. Understanding the architecture helps in effectively utilizing and managing a Kubernetes cluster.